So we have another great morning of proving finite geometry theorems. Here we're going to do theorems 5 and 6 because they're very much related. They have a special mathematical proofs relationship we'll talk about in just a second. So the first one, theorem 5, says if L and M are parallel, and then N intersects one of them, right, in this case M, then it intersects the other. So if you have two parallel lines and another line, this is like a transversal. And so if a transversal cuts one of two parallel lines, it has to cut the other. It has to intersect the other. Okay. So first, just from the given, we're going to set this up, right? And we're going to create a line L that's parallel to M. So M is the orange line. And we're going to let N intersect M at the point P. So you can see N is the red line, M is the orange line. And at the moment, they're both showing parallel to L. But we're going to proceed by contradiction. So here's where we're going to get the contradiction, right? Assume that M and N don't intersect. All right, that N tails off there and never intersects L anywhere. Well, can you see the contradiction? If you can't, you should pause the video for just a moment and see if you can find the contradiction. All right, so now that we've found the contradiction, right, we're going to apply Axiom 5. So if I apply Axiom 5 to line L and point P, Axiom 5 says that there exists for any point P not on L, there exists exactly one line through P that's parallel to L. Well, no, there's not. We have a second line here that is parallel to L, which is our contradiction. Remember, I mentioned this before. I think I've mentioned this before, but if I haven't, here you go. I grew up proving theorems at a place where the little hashtag was the symbol for contradiction. So a lot of times you'd see people do a proof by hashtag, which meant, hey, there's going to be a contradiction, and then at the point where you get the contradiction, rather than saying which contradicts Young's geometry axiom 5, right, they just do hashtag Young's geometry axiom 5. That's fine. That's a shorthand proof that you can use in my class. It's not a shorthand for proofs that you can use in my class. You have to check with another professor if you take their proof class and see if they allow you to do proof by contradiction that way. So that's a stylistic thing that you're allowed to do in my class, but it's not ubiquitous. Not every mathematician uses that same contradiction notation. All right, so theorem 6 says that two lines parallel to the same line are parallel to each other. Okay, well, you've got these two parallel lines again, L and M, and we've got two options, right? These two parallel lines, N either intersects both of them or must be parallel to both of them, right? That's the two options, 5 and 6. Well, so first, just by the given, we're going to let M and N both be parallel to L, right? And have M intersect N. So I'm using the same drawing as before. And then this, what we're saying, it doesn't have to be the same point, but we're saying if they intersect at a point P, so label the point where they intersect P, and it's on both lines M and N, and then just apply Young's geometry theorem, axiom 5 to the point P to see the contradiction, and therefore M and N must be parallel. Okay. So it's very much the same idea. And when we have a proof in mathematics that's virtually the same proof, just added one or two steps, we call that a corollary. So technically, theorem 6 is actually just a corollary of theorem 5. As soon as you know theorem 5 is true, you can apply it to the situation to prove that theorem 6 is true. And this proof could have gone slightly easier if I'd have just invoked theorem 5. Instead, I kind of went through, since I had the construction there, I kind of redid the construction, or sort of relabeled the things in the second proof according to the first one. But it really is just an immediate consequence of Young's geometry, theorems 5 and 6. Oh, and there should be a parentheses on the end of this. I will mention something here. This looks pretty busy inside this box. The double backslashes give me a hard return in LaTeX. This is a LaTeX formula. Text BF, that's giving me boldface text. And then you can see if I put all of the text inside a text command, then what's happening, that's keeping all of this stuff on the same level. So when you do this without the text commands, you get the LaTeX code parts jumping off the line, and they're maybe a third of the way up the line. It's too high. And so I know that it might be a little bit annoying to do it, but if you want everything to look great, then you just have to use the backslash text and the curly brackets around the text that you would like it to look nice. So let's take a look at this one, for example. And so you can see, right, that I have text. Then, and by the way, that space is important. Otherwise, I can't get spaces out here, right? The LaTeX editor is just going to ignore those spaces. So I have to put the space inside the little text box there. Then this is L is parallel to N, and this is an implies there exists, and then I'm back inside a text box. Notice I'm putting the space there, 2 lines on, another space here, and then P parallel to L, and then back to text with the contradicts. So yes, it can be a little annoying to type the text boxes in there, but for me it is really truly worth it, because you get these nice boxes where these nice texts where the LaTeX symbols are nicely in line with everything else. Okay, so some pro tips there about how to make your text boxes nice, and letting you know what the idea of a corollary is. So great stuff, and I'll be back soon with the last couple theorems in Young's geometry.